Ladies and gentlemen, today we explore a technological leap in electric motor efficiency, one that not only challenges long-standing industry norms, but seems to be pushing past what many thought was possible. We're talking about ABB's ultra-efficient motors, especially their IE5 synchronous reluctance designs, and the record-setting performance of large synchronous motors achieving approximately 99.13% efficiency. What does this mean? How did they do it? And why should we care? Before we proceed to the video, don't forget to hit the like button and ring the notification bell so you never miss our upcoming videos. Setting the stage. Why motor efficiency matters. Electric motors are everywhere, in factories, pumps, fans, HVAC systems, compressors, water treatment, and transportation. They consume a huge slice of global electrical energy. Even small gains in efficiency compound into enormous savings, reduced carbon emissions, and lower operational costs. ABB's recent breakthroughs. ABB has been pushing this envelope hard through multiple efforts. Two of their key recent achievements include IE5 synchronous reluctance motor, SYN-RM, family expansion. IE5 is an efficiency class defined by the IEC, the International Electrotechnical Commission. It implies ultra-premium efficiency. ABB expanded its IE5 SYN-RM motors to cover smaller frame sizes, frame 90, 100, 112, offering a power range from approximately 0.75 kilowatts up to 450 kilowatts and a speed up to 3,600 revolutions per minute. These motors are magnet-free, meaning they don't use rare earth permanent magnets, which reduces cost, supply risk, and environmental issues. New world record in motor efficiency. ABB built a synchronous electric motor for a steel plant in India that achieved 99.13% efficiency, surpassing its previous benchmark of approximately 99.05%. To put that in perspective, such motors lose only about 0.87% of electrical input to all forms of inefficiency: heat, friction, magnetic losses. That is extremely close to what many thought was near the theoretical ceiling. LV titanium variable speed motors and the EC titanium line. ABB's LV titanium motors have IE5 efficiency, cover 1.5 to 30 kilowatts, and frame sizes 71 to 160. They incorporate plug-and-play integrated drives, full torque at low speed, and are simpler to install and maintain. The EC titanium line also integrates motor plus drive, enabling variable speed operation efficiently. How they pushed the limits. So what technical advances enabled these record levels of efficiency? Some of the key enablers: synchronous reluctance motor design, rather than relying on permanent magnets or heavy magnet materials, which introduce certain losses and material cost complexity. SYN-RM uses rotor geometries that rely on reluctance, i.e. magnetic impedance, to produce torque. These designs reduce magnetic rotor losses. ABB's IE5 SYN-RM motors are magnet-free. Improved cooling, reduced rotor windage and friction. As you approach very high efficiency, even small losses, bearings, air drag inside the motor, rotor lamination losses matter. ABB appears to have optimized rotor laminations, rotor geometry, bearing design, and cooling efficiency to shave off those last unrecoverable losses. Frame size and material innovations. By expanding to smaller frame sizes and refining materials, ABB has made efficiency accessible in smaller motor applications too, not just large industrial units. Every small motor upgrade gets multiplied across many machines. What breaking the limits really means. When ABB claims new records or breaking limits, it has several layered meanings. Efficiency levels like 99.13% are extremely rare. They push very close to what physics allows. You can never have 100% due to fundamental losses. So each incremental improvement becomes much harder, more expensive, and demands better engineering. The move from IE3 to IE5 classes represents large relative gains. IE5 Syn-RM motors reportedly deliver up to 40% energy savings versus IE3 motors in many applications. That's a huge reduction in energy consumption and carbon emissions. Energy cost savings. Industries with large motor fleets, pumps, fans, compressors, etc., will see significant reductions in their electricity bills. Over the life of a motor, 10 to 20 years or more, savings can amount to millions in large plants. Carbon emissions and climate impact. Lower energy usage means less burning of fossil fuels, or less demand on the grid. For countries and companies aiming for net zero emissions, these motors help reach those goals. Faster payback. Because the performance gains are so large, the return on investment, ROI, for upgrading motors becomes shorter. ABB says that for some IE5 Syn-RM motors, the payback time can be under a couple of months, depending on the application. Broader adoption. With smaller frame sizes and more accessible motor drive integration, plug and play, more applications, not just big factories, but smaller plants, food and beverage, HVAC, water treatment, etc., can benefit. Reliability, lower maintenance. Magnet-free designs reduce potential failure modes. Improved materials and designs reduce downtime. Challenges, and what's next? No breakthrough is without constraints. Some of the remaining challenges include cost versus benefit trade-offs. Higher efficiency motors often cost more upfront. Materials, precision manufacturing. Even if payback is short in big applications, in small or low-duty ones, cost might still be a barrier. Market standards and regulation. Efficiency classes, IE3, IE4, IE5, etc., are defined internationally, but the rollout regulation in different countries lags behind. Sometimes incentives or regulations are required to drive adoption. Manufacturing precision. To get these high efficiencies, tolerances, and material quality, assembly precision must be high. This raises the bar for manufacturing and quality control. System-level matching. Even a super-efficient motor won't save energy if it is mismatched. Oversized, run at no load, inefficient drive system. The system around the motor, drive controls matching to load curves, must also be optimized. ABB's ultra-efficient motor technology has just moved the goalposts. Through IE5 Syn-RM designs, pushing efficiency beyond 99%, magnet-free operation, smaller frame sizes, and integrated drive systems, they have broken what many thought were practical limits. The result: major energy savings, lower operating costs, better environmental performance, and technology becoming accessible beyond just large industrial facilities. For industries, this could mean a new baseline expectation. For environmental goals, a concrete tool. If you enjoyed what you saw, don't forget to hit the like button and ring the notification bell so you never miss our upcoming videos. Your support means a lot to us. Take care until the next one, and feel free to drop a comment sharing your thoughts. See you soon.